Hello, everyone. Welcome to our webinar, MySQL in the Cloud. This is a joint event of Quistor together with Oracle. We are very happy that you are here to join us. Before we start, I would like to mention that we have a chat where questions can be asked, as well as some polls are available. And if you would like to vote those polls, those data will help us out a lot. You can do that at the end of the webinar or during the event. And enjoy. We will kick off with an overview of what we're going to discuss today. We're going to talk about Quistor and their operations, what we do, some of our customer cases that we jointly work on together with Oracle, as well as the Oracle framework. My colleague Dana will discuss more about MySQL, and then Karsten will give a hands-on deep dive on what MySQL is, how we can use it in the Oracle Cloud, and what are the best practices and so forth. My name is Mark, account manager at Quistor. Today I have Dana with me, who's working for MySQL at Oracle, and as well as Karsten with the very big title, but consider it as pre-sales. About Quistor, to kick off, we are a company existing 17 years now, having 12 offices, mainly in Western Europe, but we also have one office in Mexico City, working over 260 employees with 20 different nationalities and more than 250 global clients. We have our main focuses on GD AdWords managed services, data, cloud, some NetSuite, database technology solution, and application development. We have extensive knowledge and experience in IT infrastructures and of course databases as well. We support those infrastructures for 24/7, 365 days a year, and we did it both on premises and in cloud environments, mainly in Oracle Cloud. And we've been acknowledged by Oracle that we are the 2020 Cloud Partner of the Year to address our knowledge, and we target the best-in-class managed services and consulting, and that's what we always aim for. We do that via, of course, our centralized teams all over the offices. Well, then the Oracle framework, I mentioned it already briefly. Oracle framework is something that Oracle and Quistor work on together. It's the open cloud for research and education framework. That means that Quistor and Oracle are jointly working together to innovate and accelerate cloud adoption in the research and education environment all around Europe, basically. We have 6 countries that we are working together with the local end-to-end organizations to adopt and to thrive the cloud adoption in research and education. If you want to know more about Oracle Framework, you can Google it, and then you can pop up the website of the Oracle Framework, and you can find all the information there. And of course, I'm more than willing to help you out if you have any questions. Then Quistor and Oracle use cases, what we work on together. Recently, there has been a nice publication about Interfood. We've migrated the GD AdWords environment of Interfood to the Oracle Cloud. At the university, in the Oracle Framework, we have moved and improved the Oracle BI environment of the on-premises environment to the Oracle Analytics Cloud. We've implemented a very nice autonomous data warehouse solution in Oracle Analytics Cloud at the BBVA-MF, and as well as a very nice recent MySQL on-premises migration to MySQL database cloud services. So we're basically active in multiple sectors of the Oracle Cloud. Some general info about the Oracle Cloud infrastructure. Well, Oracle Cloud infrastructure is having leading database cloud technology, which we will discuss today as well with the MySQL part, of course. They aim for very high performance. We have a very high IOPS and bandwidth within Oracle Cloud, and it's often higher than our competitors. We can realize often a cost reduction of up to 40% compared to AWS, Azure, and Google Cloud. It does not account for all sectors, but this is a ballpark figure that is often realized with general services. I would like to say 70 to 80% of the products and services offered within those cloud environments are often cheaper in OCI with equal performance or even better. We have multiple database, EAS, and PaaS solutions. Today we're going to deep dive in MySQL as mentioned, but we also do SQL, NoSQL, Oracle DB, and so forth. And these database services can be combined with Autonomous. And Autonomous is a unique selling point from Oracle Cloud. It means that basically the technical maintenance of a database is done by Oracle. So it's a PaaS solution where you have only basically have to think about the functional things that you do within a database. And all the technical maintenance and support is done by Oracle, which leaves a lot of time available, of course, for the database engineers to focus on functionality instead of technical maintenance. And then we have, of course, on top of that, services for big data, data science, machine learning, and so forth. I would like to hand the word to my colleague, or not my colleague, but I work together with her very often, with Dana. She's going to talk more about the trends in the introduction to MySQL. Go ahead, Dana.
Thanks, Mark. Hi, everyone. Happy to be here today together with our close partner, Quistor. I'm Daniela Dalla. I'm the account manager for MySQL Cloud Services here at Oracle. Feel free to reach out to our colleagues at Quistor or to myself for commercial technical inquiries about MySQL Cloud. Very excited to give you an introduction about MySQL Cloud offering in Oracle Cloud. So yes, as you may know already, MySQL is not only by far the number one open source database and the second most popular database overall, but its popularity keeps rising. If you're not familiar with DB Engine rankings, this is widely known and followed, but it ranks databases based on their current popularity. And how they measure this popularity is by using a number of mentions on the website, Google Trends, frequency of technical discussion on Stack Overflow and other sites, or job offers in general. So I think it's really no surprise that MySQL is super popular and used widely also by developers. According here to Stack Overflow and JetBrains survey, MySQL remains the number one choice for developers. And this is primarily because of its ease of use, reliability, and performance. Most importantly, open source in the enterprise world is now mainstream. So open source software powers many of the most innovative applications. Leaders are choosing open source technologies to modernize their infrastructure and to use this for digital transformation initiatives. And according to Red Hat's State of Enterprise Open Source report, 90% of IT leaders are using open source today. And open source databases are the second most popular choice overall. Yes, this is not just not just words. These are facts. MySQL became very popular as part of the LAMP stack for web and e-commerce applications initially. But MySQL is very easy to use and performs well. What our users typically say is, we love it. It just works. It's just a no-brainer to choose MySQL. What probably is not so very well known is that MySQL powers many of the most popular applications on the web, such as Facebook, Twitter, LinkedIn, Pinterest. And I must say that in my conversations with customers and partners, many are surprised that MySQL is the database behind the likes of Facebook, which has close to 3 billion users. MySQL is also the transactional database for Booking.com, Netflix, and Uber's e-commerce application. And as these examples show, MySQL can perform and scale to meet the demands of the world's most trafficked applications. This is to show that MySQL is great for smaller workloads, but it's not just for smaller workloads, right? So it can be scaled and used in your core infrastructure for larger products and projects. And the names you see on the slide are not just isolated MySQL use cases. There's many companies out there, which we don't name here, that are using MySQL for many years now and happy with it. And the main reason we are all here today is because you can now use all of this greatness of MySQL in Oracle Cloud. So we do have a new offering of MySQL database service and HeatWave in Oracle Cloud. And what does that actually entitles? You can see here the various tasks which are automated by MySQL database service across the entire stack. Everything that you typically need to manually take care of in an on-premise environment in terms of hardware, storage, OS, and MySQL is automated. What we provide today is a fully managed, 100% developed by the MySQL team service, where you can deploy a highly available setup with a click of a button. So it's literally just a selection and that's it. Your system is highly available. We take care of your backup, your security patching, your upgrades, all of that. And this way, you can now focus on developing your own business and leave the administrative task of running a database to us. With our help and our partners, such as Quistor here, we can take care of your environment for a fraction of what you would pay to maintain and license an enterprise-grade environment for MySQL on-premise. Again, not just words, but facts. All the prices are publicly available, and I will actually share in the Q&A or in the chat a link where you can check and estimate. So there's a cloud estimator where you can check exactly how much your environment would be on MySQL Cloud. As you see, we are very competitively priced, and we have the same price in all data center worldwide. So unlike our competition, that price is fixed and it's the same everywhere. The service, the MySQL database service, starts at $43 a month for one CPU, 8 gigs of memory. And that's the smallest shape available, but we have larger shapes as well. I would mention here that this is the MySQL enterprise grade product that you already know from the on-premise product, with similar binaries and the same MySQL Premier support included. No hidden costs, no additional costs. That's it. You get your enterprise edition for $43 a month for one shape. Again, why would you use MySQL, which is the technology developed by our engineers and owned by Oracle, in other clouds? I wouldn't know how to answer this, because today our MySQL offering is by far the best price performance option on the market. And with this, I think I'll pass this on to our principal solution engineer, Karsten Thalheimer, again, the fancy title, who will expand on the on the offering and go a bit into more technical details for our audience. Karsten, stage is yours.
Yeah, thank you very much, Dana. Thank you very much, Mark. Okay, so let me just fix the most complicated part, the screen sharing part. So, Mark, can you see my screen? Do you agree that you see?
I can confirm.
You can confirm. Okay, that's usually the most tricky part of it. Okay, before I start presenting some slides, and I will do a lot of demos as well here, I would like to start something which we later on need. It takes about 15 to 20 minutes or something, so therefore I need to start it now so that we will see the results. We will talk about performance, and later on you probably hear me saying that I'm not the biggest supporter of benchmarking, Sysbench, and so on and so forth, because first of all, it's very often artificial, and secondly, right, you can tune those numbers in whatever way you want to, right? I'm doing kind of the same here, but I'm using an industry standard, this benchmark standard, which is TPCH, and to show you the results and to show you the difference. And I will not compare it with other services which are out there. I will just compare it with the MySQL on-premise, the MySQL version. I would like to start it, right? This is basically a couple of scripts which I'm going to run. It's running in the background during my presentation. And later on, we will see a report, something like this, and we will talk about this report once I do have the results. Just to make sure, right, so this is TPCH. This means that it's, I think, 24 queries or something. It's standardized queries. You can run exactly the same benchmark on all other services, MySQL, Postgres, Oracle, whatever, right? I do not want to comment about the other values. I'm just concentrating on HeatWave on MySQL. And as you can see, it probably takes a second until it's executed again, about 20 minutes or something, right? This gives me a bit of time to talk about MySQL from a slideware perspective, but then again, we will do a couple of live demos so that you get a feeling about how MySQL works. So as Dana already said, we're talking about MySQL. We're talking about MySQL in the cloud. We call it today the MySQL database service. And first of all, this is a full managed service. This means that Oracle is in charge of doing the upgrade, the securing of the data. It means that we are doing the backup. You can interfere with those services, right? But generally speaking, right, you do not need a lot of knowledge about MySQL MySQL. You probably set up the MySQL service and you set up your application to connect it, and that's basically what you do. Again, you can interfere with some of the things which we've done there, but generally speaking, it's a full managed service. And we are leveraging the so-called Oracle Cloud Infrastructure Gen 2, and we are leveraging the MySQL Enterprise Edition 8, which I would like to say is the latest and greatest. It is not so new anymore. Enterprise Edition is available since close to 3 years, starting April. So this is the product which we are actually focusing on. So there is no MySQL 9, and we do not have the release 5.7, which was the preprocessor of the Enterprise Edition either. So MySQL Enterprise Edition 8, that's the version which we are using. But you probably know that within the Enterprise Edition suite, we are updating the product every 3 months. So today we are at the release 28. So in fact, you can run the release 28 in the cloud, or you can run the release 27 in the cloud as well. That's basically up to your decision. And it's quite important, as Dana correctly said already, right? This is the binary which we're offering for the on-premise version as well. So it is fully compatible, right? So sometimes people speaking about migration. Honestly speaking, it's not really a migration. I transform the data from one place to another. But given that it is the same binary and the same functionality, right? The amount of work which I need to do for doing the migration is really, 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 really limited, right? And in fact, you can tweak the instance in the cloud to exactly what you're using on the on-premise version as well. So you do see a MyCNF which you can change. It's recommended to not change it, but generally speaking, you can. And this is the product, as again Dana said correctly, right? This is the product which we developed from an Oracle perspective. You probably know that Oracle took over Sun, and Sun took over MySQL in 2008. So all the developers for MySQL, in fact, they are paid by Oracle. So we are in charge of the code, we are in charge of the copyrights, we are in charge of the patents, and so on and so forth. And this is exactly what we are offering in the Oracle Cloud as well. There are a couple of options in the Oracle Cloud which you can choose. So for example, of course, we do have a clustering option in case that you want to make the service HA. But then again, the product which we are offering in the cloud, it's exactly the same technology as we are offering in the on-premise version. So in fact, on-premise, we have a functionality called group replication, or in case that you're using the tools from Oracle, from the Oracle Enterprise Edition, you are using the MySQL router, MySQL shell, then we call it InnoDB cluster. That's the same technology what we are using basically in the cloud. And the service includes a complementary Oracle Premium support. This is the same people which are supporting the on-premise version of MySQL as well. So again, you don't have to pay extra for it. So let's assume you run into a bug of MySQL, and let's say you're running in a serious bug, security related, scalability related, whatever, right? We will fix it for you. We will update the binaries, and we will update it in the cloud as well. Pretty much the same story as we are doing on the on-premise version as well. And as Dana correctly said, the service starts at $43 a month. This includes 1 OCPU, 8 GB of memory, 50 GB of disk space. All the incoming traffic is for free. All the outgoing traffic, you have to pay for it, but only after 10 terabytes of data. So not exactly sure what the price is, and 10 terabyte, let's face it, from a database perspective, that's huge. So you will probably never hit this ratio. At least I'm not aware of customers who with this ratio is, and this is only for the outgoing part of the MySQL product. In case that you've got any questions, right? So it's not just us, right? So there are people in the background. Don't hesitate to ask any questions in the chat channel. Should not be a big thing. It's just me. I cannot follow the chat channel here, so we probably look at it at the end. I'm bringing up prices, and well, how are those prices calculated, right? And again, Dana already said we do have a pricing calculator. This is just a screenshot of it, and just have a look, right? You pay by the OCPU. You can have 1, 2, 3, up to 64, and you pay by the memory. So 1 OCPU, 8 GB and 50 GB of disk storage. This, by the way, includes 50 GB of backup storage as well. Will end up at $43. Whatever number it is in euro, I don't know, but it's probably less than $40 or something. And again, right, this includes the support as well. And this is the Enterprise Edition of the MySQL product. So let's assume you are interested. So let's assume you want to run your data in the cloud. How do you get there, right? And how difficult is it? So Dana and myself, we ran an Oracle webinar last week where I basically showed how to migrate from, in this case, it was Azure, but it's exactly the same with Google. It's exactly the same with Amazon and with the on-premise product as well. So basically, right, so you've got the data somewhere else, not in the cloud. I assume that you can see my mouse here, right? And basically what you do is you download a tool which is called MySQL Shell Dump. This is, by the way, an open source tool as well. Again, Enterprise Edition is available, and we do have an open source version. And you basically dump the data to the so-called Oracle OCI object storage. Depending on your data, this can take a while. When you think of a couple of terabytes, that's something which you can do with the MySQL product as of today, right? Yeah, transforming a couple of terabytes into the cloud takes a bit of time. That's just the reality. And once the data is in the object storage, there are various ways on getting it into the database service. The most easy one, I just start a new MySQL database service from the object storage. But what I can do as well is, in case that I want to filter out data or I want to change data, you can, again, via the MySQL shell, insert this data to a new or to an existing MySQL database service. It sounds far more complicated than it is. And you'll probably hear me saying that it takes a bit of time until the data is in the cloud, depending on the size of your data. You can make this an online process as well. So for example, I just insert the data into the MySQL database service, then I build up replication, and I started at the point where I originally did the dump from my MySQL database service. And then again, right, it's completely not time critical. It can take hours, it can even take days. And then once I start the replication between the cloud and the on-premise version, well, again, a couple of minutes, a couple of hours later, the databases are in sync. And once the data is in sync, then I probably switch off my on-premise version. Again, sounds far more complicated than it is. We are offering workshops in case that you're interested in those workshops. Talk to Mark, talk to Dana. We are happy to showcase you your scenario, again, whether it is Azure, whether it is one of the German clouds, whether it is one of the Belgian cloud vendors. It really doesn't matter. The scenario is always the same. We grab the data, put it into the cloud, we build a replication, and a couple of minutes later, you should be in sync and you can switch off the old service. Should not be a big thing. I already talked about HA. HA is interesting, right? So very, very often customers are in fact looking for HA, and yes, we do have this option. This option is very, very, very simple to use. In a second, I will show you how to set up a MySQL database, and there you will probably see it's just a check mark what you're basically selecting, and that's it. And what it means is that in case that, again, right, depending on the region where you're using the MySQL database service, this, for example, I think it's somewhere mentioned, it's Frankfurt. In Frankfurt, we've got multiple regions, or we've got multiple data centers, meaning that there is a data center in Frankfurt North, Frankfurt South, and in Frankfurt East, West, in fact it is. And even in case that the whole data center, for whatever reason, is going down, right, the service continues to run in the two other data centers. And this load balancer automatically recognizes that there is something going wrong. In this case, let's say this is Frankfurt North, right? And will switch over to another instance. And again, right, this is really, really, really too simple to set up. And the real reason why you are doing it is because you have an RPO, a recovery point objective time equals 0, which basically means you will never lose any data. And when you think of a bank, for example, this is from a database perspective always the worst case scenario in terms of, well, functionality, right? That's basically what you want to, right? So you will never lose any data. This is the most critical part. And the failover time, right? We still do not guarantee it, but usually you will see a recovery time objective in a couple of minutes. The failover time is usually less than a minute nowadays. When you test it, just test it out and give it a try, right? Should be rather simple. So again, right, load balancer, you're losing the connection to the one server. The other two servers are reconfigured, they are rebound. That's again a question of a couple of milliseconds at the end, and then the application continues to run. You will never lose any data. And this is basically what you want to do with HA. It's rather straightforward. Now, you probably use MySQL already. MySQL is around for 27 years or something now, so it is established business. And the reality is that this clustering part, that's probably cool, that's new for you. But then again, there is a technology which is called replication. And MySQL, this is one of the reasons why MySQL was getting so popular in the outside world, because right from the beginning, in the mid of the 90s, right, it was possible to set up replication. So basically, you've got, we call it source today. In the past, we called it master, and you've got the slave. Nowadays, we call it a replica. And based on this replica, you have unlimited scaling at the end. You just, well, add more servers as you want to. And from a read perspective, right, you can add as many servers as you want to. Some customers do run a couple of hundred replica servers, for example, booking.com. And this basically gives you unlimited scaling in terms of reads. In terms of writes, it's a bit of a different story, but this is the reason replication is very, very often still used from customers. That's something which you can use in the cloud as well. We do support inbound, we do support outbound replication. Inbound, outbound replication was not in the product right from the beginning. We brought up this feature a bit later, but then again, in case that you really want to check where is the status, check the status as of today. About in a weekly pace, so or one feature per week, that's something which we are offering nowadays. So therefore, right, try to look at what is possible, what is not possible. And again, replication is something which is very, very often used. So for example, I mentioned it earlier on, in case that you want to migrate the data from on-premise to the cloud data center, and again, this takes a bit of time, and after this time, based on the replication, you can bring the databases into sync, meaning that you can even do an online migration without any issues. And again, you don't need the doctor's degree or something for this. This is really, really simple. You can do it in, I would say, probably less than an hour. It's easy to use, right? Again, in case that you're interested, talk to Mark, talk to Dana, and we do a workshop about this as well. In case that, in case that you think, right, I want to be even region disaster recovery aware. So you've got those 3 fault domains in one data center in Frankfurt. You've got 3 data centers in the Frankfurt region. But let's assume for whatever reason, I also want to have a copy of my data, not just in Frankfurt, but for example, also in Amsterdam or in Madrid or in Milan or in South Africa or in New York, right? You can even use the replication functionality, and you can even cluster your cluster. It's not a cluster in the remote location, it's a single service at the moment, but then again, right, this is something which is very, very easy to use. It's very, very easy to set up. Okay, before we talk about HeatWave, let's shortly jump into how the database service looks, right? As you can see, right, this is my test account. I'm starting quite some instances per day, so don't be irritated. We will look at a new instance, right? And the first one that's quite, so the first one that's quite simple. So based on the OCI technology, you've got various so-called compartments. Think of a department, and my department is called Custom Sandbox. So that's the one where I'm living from an OCI perspective. And next one is in fact just a name. So let's say this is the so-called DemoDB. And because I used DemoDB for sure in the past, let's call it DemoDB AA. A description is just a description. And then where are, right? This is the first, decision which we need to do, right? Is it a standalone system? Is it an HA system? Is it a high availability system, right? Again, most customers these days use the high availability option. Go for it, no problem. It's just you should be aware that we are running 3 instances in parallel. So obviously the price tag for high availability is a different one than the standalone. But beside of the price tag, it's the same functionality. So use it. We'll talk about HeatWave later on in case that you want to have the analytics part of MySQL as well. You have to make this decision here and say, look, I want to use this as a HeatWave cluster. Again, that's something which we're talking about in a second. For me, the standalone system, that's okay. I need to provide a username and a password. And in case that you ever seen a presentation from myself or attended a workshop, you probably know that I'm always using the same username as password, but shouldn't matter here, right? Then you set up where the MySQL instance is running in terms of networking. You can set up rather complex environment with firewalls and so on and so forth. I'm just using the existing one. I will not create a new one. That's fine for me. Then you have to decide where should the data be located. Again, 81, 82, 83, Frankfurt North, South, or East, right? Depending on where my application server lives, I will probably put the application server and the databases as close to each other as possible. 81, that's just fine for me. Then we talked about shapes already, right? And I said that there are various shapes available. The smallest one is 1 OCPU, which is the equivalent of 2 virtual threads. The biggest one is somewhere down. I don't see it. I think it's 64 OCPUs nowadays. So this is the equivalent of 128 virtual threads. The reality is that most customers are using smaller OCPU numbers, probably less than 16 or something, at least the majority of them. And then again, there is the memory attached to it. Usually it's in the ratio 8 or 16. So it's 2 OCPUs, it's 16 gigabytes, or 2 OCPUs can be 32 gigabytes as well, as you want to, right? We even have bare metal instances, but probably that's a bit of an overkill, but still it is available. It's especially available for HeatWave, so it should not be a big thing. Today, we only support the AMD shapes, AMD E3. We do not support Intel today, but then again, this is probably something which will change shortly. It's not relevant from a MySQL perspective, but be aware that's the shape which we are using. The other one is the database storage size, and probably you can, well, they changed the text here, sorry. So the biggest shape which you can use, it starts with 50 gigabytes of disk storage. The biggest one which you can use, it's 50 terabytes of, it's 64 terabytes of data. So this would be the equivalent of 50 terabyte. And once I'm going bigger, you see that the maximum amount of disk size, it's 65 terabyte. This is far too big. In my case, 100 gig or something is fine. You can configure the backup plan, right? How often do you want to back up? How often do you want to see the retention rate? Again, this is not that relevant for me. I'll just leave it as a default. And then again, you can select the configuration. I can select which MyCNF I want to use. You can create your own MyCNF files. Again, not a big thing. Just create the setting which you need and attach it to this instance. Again, very simple to use. We have a functionality called crash recovery that's enabled by default, but you can disable it. You want to disable it probably because you want to load the data very, very fast. For example, for initial setup, that probably makes sense. You can load the data probably twice as fast as compared to not using it. And when you have real big data, so let's say a couple of 100 gigabytes, a couple of terabytes, it probably makes sense to enable or to disable this functionality. Yeah, sometimes we have to restart the environment. We are in the area around a month, once per month, but you can, of course, select the time. So usually you want to select very early Monday morning or very late Sunday evening, again, depending on your business, and you can specify the reboot time here. From a networking perspective, you can set an IP address, you can set a host name. I think that's what you would expect. You can easily import the data. In case that you want to import the data, you have to import it from an object storage. So in the object storage, we are doing some magic with the data. We are validating it. For example, we are checking that there is no virus or other stuff which can somehow get dangerous to your database. So therefore, you can only import it from the database from a pub perspective. You can also import it data directly. And then, of course, you can use various tags. You press the create button, and in case that I've not missed something obvious, right, it will start the setup of the MySQL instance. It takes about 4 to 5 minutes, right, depending on the day and depending on the load of the system, but usually about 4 or 5 minutes later you have it. This is the GUI, this is something which you can use, of course, but then again, we do have all kinds of scripting tools. You can deploy it with Terraform, with Ansible. There is a thing called the Oracle Cloud command line. Again, right, it's really up to you. You can use the method, you can use the technology as you want to. This was just an entry level. And about 4 or 5 minutes later, you will have an installation, something like this. This is called Demo B now, which means that the instance is up and running. You get an overview of your instance here. Afterwards, I can decide to make this instance high available as well. This is an online process. So when I press the enable button, then I will have my clustering functionality as well. I can change some of those metrics. I can change the configuration. I can change the network. I can change the disk size, for example, as well. It's pretty much straightforward. That's something which you would expect. And you do get a kind of a basic monitoring of your environment here as well. This environment, not exactly sure what I've done with this environment today, but doesn't seem that busy right now. But at least there is a bit of load on the system. So that should be fine. Straightforward, give it a try. In case that you're interested, talk to Mark, talk to Dana. We do have free vouchers where for 30 days, and I think up to $300 or $500, depending on which voucher you get, you can use this server, and you can use at least 5 to 10 instances with the $300 or with the $500 easily, and you can try whether the replication and so on, whether it works as I have promised. So this is just a normal MySQL database part. By the way, we now call it MySQL Heatwave database service. That's a bit irritating. Even for me, it's a bit irritating. This is really new to our marketing here. But when you read MySQL Heatwave database service, that's basically what MySQL is. Now, we do have more, right? So we do have a second service. It's a bit irritating now. And originally, it was called MySQL Database Service and Heatwave. Now it is just called MySQL Heatwave. I'm sorry, marketing is probably not the strongest part of our story, but this is for ages, this is forever. When you look at what we've done from a marketing perspective with MySQL, a bit irritating. But long story made short, we do have two services, the MySQL part, the core database part, and we do have this Heatwave service. And now I would like to introduce you to the Heatwave service. Before we dive into Heatwave, a short reminder, what is MySQL, right? So this is something, again, we are not new to this business, doing it since ever. Dana mentioned Facebook, Dana mentioned Booking.com, right? This is what they do with the database. It's a relational database. It's transactional, it's asset compliant, MVCC, multi-version concurrency control. In case that you're interested in the theorems behind it, it's an ARIAS theorem database. This is pretty much the same as all the other enterprise databases as well. Just check out ARIAS theorem in Wikipedia and you get the full story. This is what we do from a MySQL perspective. And this also means it's OLTP based, online transaction processing, meaning that you've got a lot of parallel connections, and all of those parallel connections are hammering to the MySQL database and are updating it, deleting keys, updating keys, changing keys, reading keys, and so on and so forth. This is what OLTP is about. Think of a bank, think of a lot of cash machines, right? And you've got all kind of concurrency and changes, and they need to be asset compliance. So throughput is the main driver here, right? Throughput from a write perspective. MySQL is really, really good here. Again, do the benchmark with the other databases on your own, but usually MySQL is, I don't want to say we are always leading the game, but we are very often leading the game. And I'm not comparing MySQL just to, I don't know, the forks of MySQL. I'm also comparing MySQL to other enterprise databases. Do the benchmark, for example, with Microsoft SQL Server. It's quite surprising. Still, MySQL, the underlying storage engine in InnoDB, supports encryption, compression. We do have the InnoDB cluster. We talked about this as well. Again, this is more an on-premise slide here. It really doesn't matter. And we do support data up to a couple of terabytes. So there was a post last week from Booking.com from Chris Quinto, where he basically said, right, 2 terabytes, that is more or less doable with the standard configuration. Yeah, we like to see this, and I would say, yeah, this is true. But you can even do more. That's what Chris Quinto is saying as well. So probably can go up to 10 terabytes. But starting 2 terabytes is getting a bit more complicated. Memory is getting an important thing. Disk space is getting an important thing. Yeah, the theoretical limit is at 64 terabytes, and in case that you tune the InnoDB, it's probably 256 terabytes of data. So far, so good. That is what MySQL is about. Where's the issue? The issue is that you have a very good OLTP database, which is MySQL, but what if all of those connections which are hammering towards the MySQL database and suddenly you need to do complex analytic queries? Again, this is not a new issue what we have. We have seen this issue since, well, a couple of years, in fact. And usually what customers do is that they start up a new service, an OLAP-based database or a data warehouse, for example, right? Meaning that you've got another system. This is typically not MySQL. And you ETL the service, you extract, you transform, you load the data from MySQL, and you put it into the OLAP special database. So you're ETLing the data. That's kind of an issue. In case that you're into databases, you probably do not like ETLing. I am in the database space. I do not like ETL at all. But let's face it, there is no way around. But usually there is quite some complexity when you want to extract the data and when you want to load it. Even more, this data movement, that is really a pain, right? You have to make sure that really the lines are secured, that there is a firewall in place, and so on and so forth. Let's face it. Data is probably the most critical asset of your company, and then you're moving it towards networks. That's not something which you like as a DBA, but that's just the reality. You have to do it because you want to do the OLAP part. And guess what? This takes time. And by the time when the data is on the OLAP system, the data is already outdated. That's a pain. That's an issue as well. And most complicated of all is that you've got 2 databases which you have to manage now. Those other databases are, for example, it can be Redshift, it can be Synapse Analytics. Probably are using parts of Snowflake here, right? This is again something. This is their sweet spot, and this is something what you do. And this is what we do not like. We want to keep our data on MySQL. So what we've done about 2 years ago, probably 2.5 years ago now, we developed something called MySQL HeatWave for real-time analytics. So it's still MySQL. Look at this red box, right? And it's still the OLTP connections are going to this MySQL environment, but the OLAP queries, this blue box, are also going to MySQL. So the parser hasn't changed. It's a normal MySQL environment. The difference is that there is a component on the MySQL server which is called the optimizer. And the optimizer recognizes that there is a backend service which is called the analytics engine, HeatWave, or a Rapid, right? There are various names, but it's all the same at the end. And basically, the optimizer recognizes that there is an expensive query, and please execute this query not on MySQL, but execute it on the analytics engine in the background. This is more or less an on-the-fly system. So this is a real-time database, a real-time analytics database approach. That's something which you can do with the HeatWave technology. This technology needs some operational complexity. That's the reason why we are just offering it in the Oracle Cloud. So this is the normal MySQL service. You remember it when we set it up. And this is something which is going on under the hood. You, again, just need a check mark, and that's it. And you've got the analytics product. And this is, from a MySQL perspective, really cool because you can do OLTP and OLAP use cases. You can use applications like Tableau, like QLIC, like Looker, like QuickSight, or, well, you name them, right? Business intelligence applications or Python technologies. That's something which is possible. Keep in mind, the data is still stored on MySQL. There was no change. It's still the InnoDB engine which is responsible for doing the storing of the data. But given that we offload the complexity, you can suddenly store more data on MySQL than before. So this 10 terabytes of Chris Kuntrup earlier on, right? You can probably double or probably even triple it. We are testing up to 32 terabytes today, but this is really just, we are not testing much more at the moment. In reality, you can go far, far, far bigger than the 32, but we're just stopping with 32, which would equal a backend of 64 nodes. Coming back to this in a second. The price tag is also a bit different. It starts at $790 here. This is 3 instances of HeatWave for 50 gigabytes of data. You probably want to have more data because HeatWave is all about a lot of data. So it's probably $820, $830 something for the biggest storage. We have a functionality called Autopilot. So most of this operation, in fact, is done based on automation. You don't need to do a lot here. So how does it work? Again, we have our normal application. The application is connected to MySQL. The first thing is I need to make this checkbox in the cloud configuration. And this basically means that there is a new storage engine available, which is called Rapid. And this Rapid storage engine basically fires up 2 instances of HeatWave in the background. And once you load the data into MySQL, you just load it onto InnoDB. Right? So far, this is the normal MySQL product, no change at all. The new thing, which is caused by this Rapid storage engine now, is that we are creating a copy of this data. You can select which data you want to copy or which data you want to send to the HeatWave instance, whether it is just a database or just tables or probably just columns, right? That's configurable. That's not a problem at all. And basically, it means that a fraction of the table will be stored in the HeatWave backend. It's in memory only. It's columnar, it's vectorized, which means that this data, even though when it is the same data, but it lives in a different format. And in a second, you will see why we are doing it. Okay, so now we have the application. The application is running a complex query, and usually it would be executed on InnoDB. But what we are doing now is we recognize that this query, which we're going to execute, it's not a key lookup. It's not an update. It's not a delete, right? It has nothing to do with indexing, for example, right? And the optimizer recognizes that's an expensive query, and it sends the query itself not to InnoDB, but it forwards the traffic to the underlying HeatWave backend. The HeatWave backend is executing it, again, based on a vectorized, on a columnar approach. It is replying with the answer set, with the result set, and based on the MySQL system, we are replying back to the application. So again, from an application perspective, you don't need to change anything. Everything runs as it should be. In case that the query cannot be executed from HeatWave for whatever reason, for example, HeatWave system is rebooting, updating, whatever, the worst case, what can happen is that it is still executed on InnoDB, but usually what happens is that the complex query are executed in HeatWave, and they are very significant faster. In case that, I said, it's in memory only, by default, we are using 2 HeatWave instances. One HeatWave is hosting about 500 gigabytes of data. We start with 2 HeatWave instances for redundancy. So we start with 1 terabyte of data. But again, you can add as many servers as you want to. At the moment, we are soft limiting it at 64 nodes. That's exactly the 32 terabytes of data which we are using to store the data. So, yeah, why are we doing this? So that's the good question now. And now I would like to get back to my question. As you can see, the benchmark is ready. And let me just have a look what the log file is called. This is my last log file. It was executed at 3:30 UTC time. So that's my query. And this is the result set. On the left side, this is a really small database. It's just 10 gigabytes of data. The left side was executed from InnoDB. The right side was executed by Rapid. And have a look. The query number 1 here, was executed in about 100 seconds. So it took 100 seconds to execute this query. With HeatWave enabled, it just took less than a fraction of a second. And look at query number 9. Query number 9 is usually the one which is taking the longest, right? It runs for 300, about 30, 340 seconds. Query number 9 was executed again in less than a second. It takes a couple of 100 milliseconds until the Rapid cluster jumps in. That's because of the latency of the transform of the data and so on and so forth. So in fact, right, so very, very often you do not see even a second of an execution time independent of the execution time of the data on InnoDB. And this is the reason why we enabled HeatWave. So HeatWave is basically a query acceleration tool for MySQL. But when you think a bit further, it enables OLAP-based query, online analytical processing queries for an OLTP database. About 10, 15 years ago, there was an acronym called HTAP, High Transaction Processing Engine. I think it was HTAP. I'm not exactly sure anymore. From IBM it was, right? That's exactly what MySQL can do nowadays. And given that MySQL is so popular and a lot of people are storing data in MySQL, this analytical part with HeatWave, that is really the unique part. This makes it really, really simple to use it. And this, again, this was the live benchmark. Again, in case that you're interested in it, I can share the numbers, I can share the data. It is really, really simple to set up, just takes probably 5 to 10 minutes. It's probably better to run it with your real data to see, well, what is the real data? What is the real value add? But in this case, right, it is not unusual that for some queries, the HeatWave engine compared to the InnoDB engine, so it's MySQL versus MySQL, don't get me wrong here, right? It's in the area of 400, 500, 600 times, depending on which versions you compare, faster. So a query which runs for 600 seconds on native MySQL, doesn't matter whether it is on premise or whether it is in the cloud, it's executed in less than a second with HeatWave. So let me come back to, once I do have my mouse back, to my slides. So, and this is just a placeholder. This is a different, it's the same benchmark. It's just a placeholder for me to remember it. So from a pricing perspective, again, let's go back to the pricing. Pricing is always very expensive. And as you can see, this is based on nodes, right? And the minimum amount is you need 3 nodes. You need a MySQL leading node. When you remember this picture which I showed earlier on, this was the left side. And those are the 2 HeatWave backends. And the cost per node is in the area of $260 plus the storage. You don't pay for the CPU, don't pay for the memory anymore, which ends up at the end with about $790, $800, and $810 in case that you add a bit more storage here. Now, the direct comparison for this, in fact, is Amazon. And okay, let's do the analysis here. Again, I'm not a big supporter of this idea, so I will go over this quickly, right? When you compare MySQL HeatWave versus Amazon RDS, this is the entry-level product from an Amazon perspective. Therefore, I think that this is a stupid slide, but anyhow, right? We are very significant faster, 5,000 times faster. But again, forget it, right? It's 2/3 the cost. I don't like this slide, full stop. Now, Aurora is getting, a bit more serious from my perspective, because when you really want to store a lot of data, so think of 15, 20 terabytes, right? Then that's probably something where Amazon would like to say, right, use the Aurora product. It does have HA, it does have this, and so on and so forth. So this is probably a more realistic comparison. But even here, right, we are 1,000 times faster for only half the cost. But those of you who do know Amazon, they probably say, right, this is even not a fair comparison, because this OLAP-based approach, the data warehouse approach, that is probably something which you would do with Redshift. And I totally agree. You are absolutely right. So this is, I would say, that's a fair approach, right? But even then, right, depending on which selection you use on the Redshift side, Redshift Aqua side here. In this case, it's 7 times faster, and it's only still half the cost. We are faster, and it's still half the cost. Then again, this benchmark is published in GitHub. You can run this benchmark. Again, I don't want to say that this is a perfect benchmark, but this is the story. In case that you're running Redshift, or the equivalent product from Microsoft is called Synapse, or it is called a Google BigQuery from Google perspective. Our product is called HeatWave in these terms, and this is something where we are competing with. But then again, the cost is the very important point here, and this is something where we can easily compare. And when you run complex dashboard, this is the Oracle Analytics Cloud. The same for Tableau, the same for Looker, the same for others, right? That's something which you can easily do nowadays with HeatWave. Given that it's a normal MySQL parser, all of those applications will run without any issues. So this is kind of a summary, but I do not want to go to the summary yet. I want to do a bit of a live demo here as well. So what I did is, okay, let me just sort my pictures. So I prepared an HeatWave session already. And again, you remember how it looked like, right? Again, you can set up an HeatWave session in, I don't know, 10 minutes or something. It looks like a normal MySQL environment. The only difference, which you probably recognize, is that it says HeatWave enabled. In this case, I added 3 nodes. I'm not exactly sure why I selected 3 nodes, but anyhow, right, it's 3 nodes. And this is the only difference which you will recognize towards a normal MySQL system. There is some, monitoring, extra monitoring available for the HeatWave environment. Well, this is not really relevant. It is a normal MySQL instance. And what I did, one of the most common applications, one of the most common MySQL product is called MySQL Workbench, which is the client interface for MySQL. And guess what? It does work for HeatWave as well. So let me do something here. So I connected to this HeatWave environment. I do have TPC H1, 2, 3, 10. This was the tool where we used the benchmark with as well, right? And let me just do on query number 1 from the TPCH benchmark on TPCH1. So this is 1 gigabyte of data, and this is the query 1 from TPCH. So, okay, I'm running this query, and I speculate that this query will, run for about 10 seconds. So there we are. It's exactly, okay. Okay, that's a random effect. Now it's exactly 10 seconds. Okay, now in case that I would run the same query with 2 gigabytes of data, just think a second about, right? How long will the memory execution, all this data exists in memory, how long will it take? And 20 seconds is the answer. It's probably 18, it's probably 22 seconds, but twice the data, in fact, means twice the time for executing this query. So rather simple at the end. So now let me do a trick here, right? So I've not auto-loaded this data. So this is something which I manually need to do. Again, this query took 10 seconds. I will load my query now. Again, it wasn't auto-loaded for me. I will run this query. So this takes, I don't know, a couple of seconds, a couple of milliseconds. This basically means that all of those tables here are loaded from my MySQL leading node, because this is the persisting storage, into the memory of my HeatWave node. And what I will do is I will run this query again. Oops, no, what's happening here? Hey, come on, hurry up. Okay. Okay, something was happening here. Probably I pressed the button again, but doesn't matter. Okay, now I run this query again. And you can see that the same query, it's exactly the same result set as before, is executed in less than a second. And this is what HeatWave is about. The query hasn't changed. Everything is more or less automated. It wasn't automated for me to show you what is going on, but all the handling of the HeatWave environment, right? It's pretty much the same story as what we've learned with the normal MySQL product. So for example, when you go to the Show Engines button, right? Again, it's a normal MySQL environment, right? The only thing which is new is Rapid. Rapid, by the way, was the internal code name of HeatWave, real-time analytics processes in DRAM. So Rapid was the internal name. We've not changed the name. Again, we are not good from a marketing perspective. Call it HeatWave Engine, and this is basically HeatWave Engine. So when you check out whether your instance is running, again, that's something which you should do as part of the setup of the MySQL setup in the cloud. Again, the Rapid service is up and running. We do have various modes. You can have a snapshot mode, or you can have a change propagation mode. This basically, this basically means that what if the data changes now? So what if I add data constantly to my environment? Do I want to keep the HeatWave nodes in sync? You can. That's again happening on the bin logs. You probably know this concept from the replication or from the clustering already. Or you can use a snapshot as well, meaning that I create a snapshot once per day, and then I'm just doing the analytics part on my snapshot. This is not real-time analytics anymore, but both models are possible, right? The default is change propagation is on. I can check which data is in my heatwave environment. Again, everything is based on the performance schema. That's a normal MySQL concept. In my scenario, yeah, I did the test with the 10 gigabytes. This was the default when I set up the instance. I just loaded the TPCH1 database. I excluded the others. So those tables, those databases, those schemas, they are in fact running in the heatwave engine now. And whenever you do a select now, what basically happens is that based on the cost of the environment, by the way, let me do this query here. So I'm doing the query here now, and let me check what the cost of this query is. So this query, the last execution cost was 6,500 units, and everything which is cheaper than 100,000 units, in fact, is executed on the normal InnoDB system, and only those queries which are more expensive than 100,000 units are executed on heatwave. You can specify this value. 100,000 is just the default, but from a session perspective, you can set this value, and you can easily select which queries should be executed in heatwave and which queries should be executed in InnoDB. Updates, deletes, inserts are usually executed on the InnoDB system, whereby complex queries or single key lookbacks, they are executed on InnoDB as well, but more complex queries where you're running joins or sums or any other mathematical operations are executed in the backend. This is what heatwave is about. This is something which you can do. Today, you can only do it in the Oracle Cloud. This is the status as of today. Never say never. Stay tuned. Try to follow what's coming up in the press here. But today, it's only available in the Oracle Cloud from our perspective. Let me come to the end with my slides. Again, so MySQL and heatwave, it's a single database for OLTP and for analytics usage. All application will work without any change. Based on the autopilot thing, right, you do not even need to know one single command from a MySQL, from a heatwave perspective. But then again, we are DBAs, you want to fiddle around with the data, so I can switch off parts of the autopilot in case that you want to. But in case that you're a business intelligent person, in case that you're a data analyst or a data scientist, you probably do not want to interact with the data. You're just interested in the SQL or in the Python or whatever code you're using there. That's something which you can do. And it's mainly there to accelerate the business, but then again, meaning that you can store far more data on the MySQL system and you can do very complex analytical approaches. You do not need to use a Redshift, a Google BigQuery, a Synapse, or whatever technology anymore. And this is the main reason for heatwave. And again, this was all about marketing. In case that you really want to see how it does work for you, get in contact with Bob, get in contact with Dana. We have those vouchers, try it out. We will support you on setting it up, but then again, it's really, really simple. You will set up this environment in 15 to 20 minutes, depending on how big your data is. You probably installate the data. This probably takes a bit longer, but then again, we are here to help. So, that's it from my side, and I would like to hand over to Mark. I heard a lot of beeps, so are there a lot of questions, Mark?
Well, there have been some questions in the chat, but they've been answered already by...
okay, cool.
Or mostly. Yeah, I'm wondering if anyone else have any questions. This is the moment to ask them, because otherwise we're going to wrap up the webinar. We're just in time, 1 minute to 4. So that's well scheduled.
That's the first time.
Don't happen that often, yeah.
Yeah. I would like to ask kindly if you have seen the polls already, or if you have not seen the polls already, please take a look and vote. The data would help us a lot about our audience and the way they use MySQL. I don't see any questions coming in, so I think that we can wrap it up. We have a pop-up here. If you're interested in the MySQL for free, you can click the link. It will redirect you to the page where you can sign up for a free tier account. And if you have any questions, you can always reach out to me or Dana, or I think that will be the most convenient to reach out to me or Dana. And if necessary, we can get you in contact with Karsten as well. Yeah, thank you for your attendance, and hope to see you soon in the future. Thank you all.
Thank you all. Bye now.